Let's talk about onion architecture so that we can grow an application without it collapsing on itself.
You are programming with Palermo. You deliver software. You need to move fast, deliver quality, and run your software with confidence. Stay tuned for timeless solutions, simple methods, and topics that will propel you forward. And now your host, lifelong programmer, author, teacher, coach, Christian, and charismatic speaker, Jeffrey Palermo.
You've witnessed a code base, I'm sure, that was so coupled, was so difficult to change. Changing one thing caused two other things to break in a seemingly different part of the code base, totally unrelated. So then you become afraid to make changes. And after that happens, refactoring to better patterns, it just stops so that you can avoid those breakages. And then when development slows, it produces more bugs than it fixes, or maybe it causes disruption in production. It's a symptom of a flawed architecture. And flawed architecture doesn't just mean that, hey, maybe your web app should have been a desktop or a mobile app. No. It means that there's an architectural element missing. And when you find yourself drowning in a mountain of development work, just stop and back up and look for an architectural solution. So today we're going to talk about an architectural solution to code organization and dependency management. Back in around 2008, I published some articles on onion architecture, which has some specific tenets for managing dependencies and the different types of code in an application. Since then, onion architecture has been published and referenced in books and other articles, and you can find plenty of tutorials online. Now, there is a specific type of organizational structure for an application, and that's what I call onion architecture. I found that it leads to more maintainable applications since it emphasizes separation of concerns throughout the system. And I have to set the context for this so that we can proceed and really talk about it. This architecture is not appropriate for just small websites or tiny applications with one or two screens or functions, or small things that are short-lived or so targeted where you can basically memorize the whole code base and see it all together. No. It's appropriate for long-lived business applications, as well as applications with complex behavior, for example. It emphasizes the use of interfaces for behavior contracts, and it forces the externalization of infrastructure. So let's take a look. Okay, the diagram that you see here is a representation of traditional layered architecture. This is the basic architecture I see most frequently. Each subsequent layer depends on the layers beneath it, and then every normal layer will depend on some common infrastructure and utility services. The biggest drawback to this top-down layered approach is the coupling that it creates. Each layer is coupled to the layers below it, and each layer is often coupled to various infrastructure concerns. Without coupling of some kind, our system actually wouldn't do anything useful. But this architecture creates unnecessary coupling. And the biggest offender and the most common is the coupling of UI and business logic to data access. Yes, UI user interface is coupled to data access with this approach. Transitive dependencies are still dependencies. UI depends on business logic, which depends on data. So therefore, if you change something in data, it cascades up to business logic, cascades up to UI. So you have transitive dependencies. The business logic can't function if, in this example, data access isn't there. And so likewise. Now, I'm intentionally ignoring the infrastructure part that's common here because this typically varies from system to system. And data access, it changes really frequently. Historically, the industry has modified data access techniques at least every 3 years. So we can count on needing to modify data access 3 years from now for any healthy, long-lived systems that are mission critical to the business. Just think back to the last 3 years and what frameworks and versions have come out and what's changed. You don't want those changes cascading all over your application. Now, we often don't keep our code bases up to date because it's impossible to do with this architecture. If coupling prevents easily upgrading parts of the system, then our companies, the business, has no choice but to just let those systems fall behind in a state of disrepair because we can't keep changing them and dealing with the breaking changes. And this is how legacy systems become. They become stale. And eventually the teams are calling for rewrites because we can't do anything for them anymore. So back in 2008, I proposed a new approach to application architecture. Now, honestly, it wasn't completely new back then, as a way of thinking, but I proposed it as a named architectural pattern. And patterns are useful because it gives software professionals a common vocabulary that we can use to communicate. And there are a lot of aspects to onion architecture, and if we have a common term to describe this approach, then we can communicate more effectively. Now, the diagram next is it depicts the onion architecture. And I have to give credit to Sean Whitesell for this beautiful diagram, much better than my original diagram that I built back in 2008. But the main premise here is that it controls coupling. The fundamental rule is that all code can depend on layers more central to it, but code cannot depend on layers further out from the core. And so in other words, all coupling is towards the center. The architecture is unashamedly biased towards object-oriented programming, and it puts objects before all others. So we're not record sets or data-centric. We are assuming that we are using to the fullest object-oriented programming. And in the very center, we see the domain model, which of course is a term that references to domain-driven design. So if you're not familiar with that, you want to go research that so that you just understand that. But it's a method that uses object-oriented programming to build business applications. So in the very center, we see that core object model, the domain model, which represents the state, the behavior combination that models the truth for the organization that is using this application. And around that core domain model, those core objects, are other layers with more behavior. And the number of layers in the application core is going to vary. You think of namespaces, it's going to vary, and those aren't as important as actually having a project that is called core, C-O-R-E, and that you protect it from all other dependencies. But however you organize your namespaces, remember that the domain model is the very center. And since all coupling is toward the center, the domain model is only coupled to itself. The first layer around the domain model is typically where we find interfaces and other abstractions, the gateway to the outside. And if every application needs that, and I guarantee every single application needs abstractions. It needs them to deal with retrieval and saving data, for example. Every application needs to get some type of data and save that type of data. The object saving behavior is not in the application core, however, because it typically involves a data storage dependency, whether it's SQL Server, queues, blobs, files, however you store your data. Only the abstraction is in the application core. And when I say abstraction, .NET interfaces are your most common abstraction, but even classes can be designed as abstractions if they define a contract or pinch point in the code base. Out on the edges, we see UI, user interface. We see infrastructure, tests, and whatever else uses really useful libraries and NuGet packages. The outer layer is reserved for things like that change often and change out of our own development schedule. So these things should be intentionally isolated from the application core. Out on the edge, we find a class that implements an interface or abstraction. For example, saving to a SQL Server database. That particular class is coupled to that particular method of data access. And modern applications, you'd be using Entity Framework, an object relational mapper. You'd be using a library that is going to change out from under you. So Microsoft, somebody else is going to make changes to it and give you a new version. And these types of classes implement the interfaces of your core, use the outside library, and is thereby coupled to the library. Code that uses outside libraries such as NuGet packages will always change more frequently than code that only depends on other code in your code base. Now, the onion architecture also relies heavily on the dependency inversion principle. you're not familiar with that, just do a Google search, dependency inversion principle. The application core needs the implementation of core interfaces, and if those implementing classes reside at the edge of the application in outer layers of the onion, then we need some mechanism for injecting that code at runtime so that the application can do something useful. The database is not the center, it is external. Externalizing the database can be quite a change for some people used to thinking about applications as database applications or web applications or a Azure Blob application. With Onion architecture, there are no database applications or insert infrastructure word here applications. There are applications that might use a database as a storage service, but only through some external infrastructure code that implements an interface which makes sense to the application core. Decoupling the application from the database, the file system, or whatever you use, lowers the cost of maintenance for the life of the application. And for those who do like to research, I'd like to give some references. Before I first wrote about Onion architecture, Alistair Coburn wrote about hexagonal architecture. And hexagonal architecture and Onion architecture share the following premise: externalize infrastructure and write adapter code so that the infrastructure does not become tightly coupled. All right. And in recent years, Bob Martin has written a book called Clean Architecture, and his approach is also leverages prior art and builds upon the shared concept of intentionally organizing code so that coupling is managed. And if you'd like to catch up on prior publishing about Onion architecture, you can search jeffreypalermo.com and find the original articles. I'll leave you with the 4 tenets of Onion architecture, and they are: first, the application is built around an independent object model. All right. Number 2, the inner layers define interfaces, the outer layers implement the interfaces. Number 3, the direction of coupling is toward the center. And number 4, all application core code can be compiled and run separate from the infrastructure. There is so much more to dig into regarding Onion architecture. If you have a comment or question, please write to the show. And thanks so much for Programming with Palermo.
You've been watching Programming with Palermo, your primary place for highly productive programming protocols and practices. Remember, you have what it takes. You can do this. You are a programmer, formed by God Himself and called to this profession for a purpose. You can catch every episode at Palermo.network, as well as syndicated locations nationwide. We're so glad you tuned in. Until next time, may God bless you, and thanks for Programming with Palermo. Programming with Palermo has made a special arrangement with Marketplace Chaplains. Besides programming challenges, we all face issues in life where we need some help. If you'd like, you can call a chaplain confidentially. To speak with a gentleman, dial 512-923-8178. Or to speak with a lady, dial 512-619-6950. The show won't know you called, and everything is kept in strict secrecy. This is a free service, available if you or a friend need it.